love clapperboards, dude. It really makes a lot of sense to have clapperboards if you think about it. All right, I'm gonna try. I'm gonna try video. I recorded one a couple days ago, and then I never did anything with it because I thought it was dumb. Um, but I'm gonna try another one because one of the things that I'm working on for this, I guess, image board. I feel like that's kind of an appropriate name for it, but this image board is tag synonyms, and now I'm about ready to finish implementing the interface for that, which is going to be a endpoint in my HTTP API. So I have the database implementation all set, and I might go through that later if I'm feeling bored. But what prompted me to start recording this video is the fact that kind of the interface, or well, not really the interface, but the way that I have my data modeled is really starting to piss me off. And I figured that I would record so that I can kind of like complain about that, I suppose. So I'm gonna write up this feature as I'm working, and then I'm gonna complain about what you see in front of you, and then talk about some do's and don'ts of data families, because I have some good or decent examples of using data families in code, and then I also have some really bad examples, which is what we're looking at here. So, right, label synonym. So I'm not going to go over the difference between a label and a tag here, because that's a dead horse that I've beaten a lot. And as always, I struggle with naming things. I don't want to call this a label synonym, because it's really supposed to be, what I'm trying to make is the data type that gets read from the request body when someone sends a request to this API endpoint, to this endpoint, to make a label synonym. So like it's supposed to be this thing, which I just have as text right now because that's a placeholder, but that's going to be something different. But it should be something different, like a synonym request, or synonym put request body or something. I don't know. Really, I guess I should make this. That should be a put, but because this is all HTML, it's a post. So just because. So anyways, yeah, I have to think real quick. I'm going to brainstorm a better name for this because I don't like calling this a label synonym. So let me think of something better to do here. I have here data types to, like, for an insert form, which is not, I'm not really inserting anything. So I don't know about that. Well, actually, you know what? I don't think that's half bad. Let's do that. Label, insert form synonym. We'll call it that. How does that sound? This, of course, is a data instance of the data family label. So maybe I'll get over that. Maybe I'll cover that, what exactly that is, because it's different than a data declaration. But this insert form synonym doesn't actually like have any bearing on the data that is contained inside of this declaration at all. It's just it's what we call a type index. So it's just kind of like semantically useful, I guess, denotationally useful. I don't know what the correct word for that is, but it doesn't actually mean anything about the data that this type is going to hold. So we can call it whatever we want. And usually when I'm naming these instances, I just smash everything together just like that. And so this is going to be label insert form synonym, and I'm using generic deriving for everything in lenses and stuff, so that's why these all have this kind of naming scheme. But this is just going to call it like this, synonym, and then this is going to hold a text key, which a text key is just a text new type. So it's just, think of it as text, because that's basically exactly what it is. So go ahead and then just derive show for it because we can, and then deriving from JSON via default generic JSON label insert form synonym. Okay, so that gives us that. And then I also want to have from form too, right? So I'm deriving from form via default generic form label insert form synonym. Okay, and there we go. Maybe this should be okay. Now hold on. Let me have a new index. So let me export this synonym here key. We will change this to label insert form synonym, and that should fix our problems. Okay, so there's that. Perfect. Now let me take a drink real quick. I'm drinking Squirt and Tequila, which is a pretty good combo. Normally you'd also put some tahini in there, but I couldn't find my tahini, so I'm tahini-less. There's no tahini. But let me tell you, if I had tahini, it should be bussin'. Okay, so we've got this. Let me actually just call this a new type. I have these two things here for deriving via, because this is an instance of generic. So this just lets me derive these like pretty mechanical type classes via these new types that I have defined here in these instances. So don't worry about what exactly that means, because really you shouldn't even need to do something like this to derive these two classes. But there's a couple of like options that I want to use that's a little bit different than the normal generic deriving options. So I just have these new type wrappers to handle that for me. So that's what those are. So don't worry about those. Also, if you want to make a generic new type wrapper for a class for from form and to form, it's really annoying because this G from form class, which is a generic helper that's defined in the library, is not exposed by the normal module. It's exposed as in the internal module. So you have to import the internal module to use it, which is really annoying because ASON uses like the same kind of like scheme for its generic type classes, but its generic class is exposed in the normal module, so you can just import that directly without having to do any import internal shenanigans. So just keep that in mind next time you're writing generic instances. So, okay, now let's see. Yeah, so here's our endpoint. So when you send a request, when you send a post to an endpoint with this request body, what you're saying is that this label here is going to have a new synonym, which is this label here that you're sending in. So I will go ahead and do this real quick, and then we'll do a live coding demonstration, and I'll show you how that's supposed to look. So let me implement this. This guy, query server. What should I call this? I hate naming things because I'm bad at it, and I think it's really important to name things well, but I'm just not good enough at it to be satisfied by the names that I come up with. Synonym. I'll just call it synonym post server. How's that sound? Label synonym post. Label synonym post server. Okay, and then here's our there's our label one. I don't really care about naming variables all that much because they're not as important to name as functions, especially with Haskell. So don't give me none of that shit about variables should have useful names. It's like these functions aren't that long. Just read. How's that sound, huh? I know that we take some authorization as an input to this endpoint, but I only care about authorization insofar as that a user is authorized to do this action. So I don't care about what user is doing this. I just care that they're authorized. So I'm gonna ignore that. That's what that underscore is for. Ignore that. And then here is our label insert form synonym L2. Okay, and then wrap this in our base server new type, which is the monad that our server runs in, which is just a new type wrapper over an effect stack. So don't worry about what none of that means. It don't matter. Let's do this. Base server dot fmap const no content, and then this is what did I call this thing? Merge label synonyms. Okay, so the reason this function is called merge label synonyms is because label synonyms in the backend are implemented as a disjoint set. And so when you're creating synonyms, what you're doing is you're merging two sets together. So just in case you wanted to know. Merge label synonyms. And then these should be texts. Right, this is supposed to be text. Or text key. Okay, no, that's fine. Okay. L1, L2, perfect. All right, so then there's that. Now we go back here, throw this up here, labels, and then post server, perfect. Okay, there's our implementation of our server backend. So now let's fire this baby up, try it out. Let's go ahead and try this. I have to run the help command because I always forget what the input to this program is. These module names are completely brain dead. I need to change these. Okay, so I'm gonna, while we're here, I'm gonna just make a new project here inside this folder. So you can see how that works because it's kind of cool, but I think that would just be easiest if I do that. So new, I think we can have an empty password. I can't remember if it'll let us do that or not. Let's try that. Okay. Oh, what the heck? Oh, no. So that's why it's not going to let me do that. I should fix that because that is a really disgusting looking error. Please enter a... Oh, hold on. No, I just did it wrong. Let me try that again. Not very smart. Hold on. All right, perfect. There we go. So now if we go here... all right, now here's our new project. There's nothing in it. There's nothing in it because I haven't uploaded anything. So let's go ahead and upload a file. Let's upload an ADHD diagnosis. This is my official ADHD diagnosis that I received from an online test, so you know that it's real. I need to change this default query. Since I updated the query language, the default query is actually not correct because this symbol is not in the language anymore. So I need to update that. But anyways, now let's go ahead and let me just upload 2 more, and then I'll give you an example of what some of these. This is a YouTube thumbnail. I screenshot it because I thought it was ridiculous. Let's see, there's a Yui picture, there's another Yui picture, little background. Some of these I don't remember. Brutally bashing, on the head. I would do that, but I know that these GIFs don't get their thumbnails created correctly, so I'm going to ignore that. I'll just do this and just keep it simple. Okay. Now we got these 3 things. Let's go ahead and just add some tags here. Tag it, that. Oops. Search B, C, three different tags. So if I search A, I get one thing. If I search B, I get another thing. If I search C, I get another thing, right? Okay, so now let's try post here. So curl, if I can remember exactly how to do this, inch content type, location, JSON, data, synonym, B. Let's make B a synonym of A. And then I can already tell that this is not going to work, and I'll tell you why after I show you why this doesn't work. Well, actually, what's going to happen? I don't know. Let's find out. Localhost 80/label/A. Let's go ahead and make this books. Okay. 401 unauthorized. I forgot to send my authorization. Is it authorization? Is that the whole thing? I can't remember. Okay, let's see if I can do this on the fly here, because I don't quite remember how to do this either. Base 64. I think that. Bad request. Okay. I think that is what I'm expecting to get. Maybe. Parsing text failed. Expected string but encountered object. Hold on. Okay, hold on. Hold on here. I'm confused about this. Oh, you know what? All right, there's a couple things going on. One of these is definitely my fault. I think what I want to do is make this data and not a new type. Oops. Since I've already run new on that, I don't need to run it again. And it'll actually give me an error if I try to. Okay. All right. Now let's try this. Okay. Hold on, folks. What do we got? Wrap unary records true. Blah, tag single constructors. I think that's what I wanted to do. From JSON to sJSON. Let me try something real quick. Can't all be winners, folks. Label, insert, forms, and then was it to JSON? I think that works. Bruh, haha. Set overloaded strings because Haskell's kind of stupid. String, bruh. Okay, so that is not doing what I think it's supposed to do. Hold on. Why not? Default generic JSON. Why is this not? This might be a bug actually in this encoding that I thought was supposed to be doing something but is doing something else. Tag single constructors false. Okay, hold on. I just want to try this. I'm going to change that back. Don't worry. Okay, yep. Ew, actually, no. What the hell? What? Ew, no. No, absolutely not. Okay, we're going to do this the old-fashioned way here instead of these guys here. We're going to just do these by hand. So because of these default options that I have set, if a data constructor has only one, or if a data type is only one constructor, and I guess if that constructor has one field, then it will just like ignore this wrapping and just return the JSON of whatever's inside, which I think is a good thing, because by default in ASON that's off, and that always irritated me. Whenever you're wrapping a new type in a type that is JSON serializable, then ASON will encode that as being inside of like a new type object in JSON, which is not, it's not what new types are supposed to do. If you derive a class with a new type deriving, it's supposed to ignore the fact that it's a new type, right? If you're just doing deriving via new type, it should just ignore that. So that always bugged me. So that makes sense why that's happening. I thought that I had changed that for this, or I just forgot what my own code does. But no, that's what I wanted to do. So we'll just do this here from JSON, and then we'll just write this instance by hand because it's really not that hard. Where parse JSON is with object label insert form synonym label insert form synonym, and then this is synonym like that. I don't know why I did that. It's annoying, but oh well. Okay, and then there's this, and then there's that's not it. I'm looking in the wrong place here. Okay, got this guy. Because what I'm looking for is like a singleton object, right, with this field, right? And then we basically have to do the same thing here. So for form URL encoded data, which is going to be very similar. Where from form f is label insert. Can you not, please? I don't know why it's doing this. Stop. Gosh. Okay. And then I just don't remember. Lookup maybe. Lookup unique. Lookup unique is fine. That's what I'm kind of looking for. Yeah. Lookup unique. Synonym form. And what is this freaking mad about text? Okay. Alright. Now, alright. Now. This doesn't have a toJSON instance anymore, so that's not going to matter. Okay, now let's. Please excuse these interruptions. This is all part of the fun. Let's rerun this. Let's try a curl request again. It's still going to fail, but I'm expecting a 500 and not a 400. So 204, no content. That actually worked. I don't think that it did, but I guess let's see if it did. I'll tell you why I didn't expect it to work here in a moment once I test this. So, okay, so what I was trying to do is make B a synonym of A. So if I search A, then I should get both of these results back, because this has A, this has B, but they're synonyms, so they're technically the same, right? And then if I search B, I should also get both of them back, right? So I just get the one, which is what I expected because it didn't actually work. Let's see, okay, so now I'll show you what is wrong here. So the implementation in a database takes these text values and then just inserts into this view here, which the view itself doesn't actually return any data, or rather it returns two null values. So I just have it as basically like a method name. And then when you insert into it, there's a trigger that fires instead of insert on this view. So it's kind of janky, but I did that so that I could keep most of this implementation just in SQL. And so I didn't have to screw around with like application code too much. But the reason this didn't work is because this function, if you will, takes two integers and not two text values. And the integers are the primary keys of these two labels. So what we need to do, first of all, is find the values, or the primary keys of these. Why am I finding that so difficult to do? Okay. Anyways, what I will do, and then since I have some constraints on these tables, right? So a label is unique, not text, not null, create unique index, right? So labels are unique, so I can just go for equality here, and then this is fine. Normally what I would do with labels is I would use a like comparison, but that's really only for queries, just to make them easier to write. So, and this is not a query, it's like supposed to be like a real useful endpoint, right? So this is just, I can just use equality here. So insert into label, select K1, maybe this will work. Maybe this, I have no idea actually. I kind of feel like this should work, but the active label where label equals that. I think that's what I want. Don't judge me too harshly on my SQL skills or lack thereof, okay, please. And then we'll just do this one too. Label where, okay. I think that's what I want to do. Now this should do what I want. So let's rerun that. Let's try it again. See what happens. Let's try it out. And actually one thing that I can do real quick is I have access to the database. Let's go ahead and just open it and take a look. Yeah, okay, so it didn't actually do anything because the way that this is represented is a disjoint set. Each of these labels is represented by itself, which means that nothing had changed. So once I make A and B synonyms, then I would expect this to be 1, 1, 2, 1, 3, 3, right? So let's do that. 500, okay. Yeah, that's kind of what I figured would happen. No such column K. And there is no such column K because there is, in fact, it's called ID. I don't know why I chose K. It's like I'm not operating at full brain capacity here. Let's try again. Let's try again, folks. 204. Okay, now. There we go. See? The magic bit flipped. Now if I go back here, and then if I search A, we get both of them. Perfect. Look at that. Look at that. Get like all of these that come up because I was searching for these on my Huey database. See, okay, perfect. All right, there you go. There you go, folks. Mission complete. Mission complete. All right, let's go ahead and clean up a little bit. I don't know, what is it complaining about here? What is it mad about? Okay, get rid of that. We'll make sure that our files are somewhat sanitary before we make any commits, of course. I don't have a test suite to run on this because writing tests is for losers, and I've not felt like doing that yet. So I have this entire code base that is entirely untested. But, that's what types are for, that's what I always say. All right, looks good to me, brother. Ship it up. Ship it up, brother. Make sure I don't have any extra files hanging around. What changed in here though? What is this? Oh, I moved something. 2 spaces, right? Maybe. I'll just make it one. Okay, I moved this view down here. Okay. Okay, looks good. Looks good to me, brother. Me add endpoint 4, making your label synonyms, blah blah blah. How's that? That looks pretty good. I'm hearing some noise coming from downstairs. The printer just turned on for some reason. Oh! Database is locked, the hell. Why are you doing that to me, brother? Unchanged checking command, yes. Okay, there we go. Alright, I don't know, it's kind of weird, but it worked. Worked second time. Second time's a charm. Okay. Here's my fossil repo. Let me see. It's windy outside. Okay. Okay, so yeah, that's that. All done. Looks good. Project's complete. No more changes planned. That's all you need, folks. Now I'm going to talk about data families a little bit. I showed you an example of I showed you a bad example of data families, which is like this stuff. Because I'm using these data families to represent like basically every possible data type that has something vaguely related to do with an image, or a label or a tag or something like that. And it turns out that's just like really stupid because it just makes things confusing. It's not stupid because it's like necessarily bad. It's just stupid because it's kind of just like decoupled and difficult to keep track of. Or decoupled is not the right word because I think decoupling is usually a good thing. But like this irritates me. I shouldn't have ever done that. So that'll be something that I change eventually, although it's going to be a pain in the ass to do that. But anyways, to show what I think is a good example of data families, I have this here in my query module. When you write a query, it gets first of all parsed into this DSL, which is encoded tagless finally. It's a tagless final encoding of a DSL. And then one of the interpreters for this DSL, which actually is the only one right now because I haven't written anything, but one of them is basically just compiles an expression in this DSL to a SQL query, and then also tracks like all of the parameters that you're binding to the query and stuff, of course, right? Because the query would be useless if you couldn't bind parameters to it. So, right, it does all this crap in here. Right, so, it's like normal stuff. But anyways, this where is it? This data family, this predicate data family, I think is a better example because it is, first of all, like instances of this type are constrained to this module, right? Maybe? No, they're not. You could define an instance of it elsewhere, but it doesn't matter. The semantic meaning of this data family is constrained to this module. Outside of this module, it doesn't really mean anything to make an instance of this predicate type. So it would kind of be an error to do so, to make an instance of it. So I think it's just kind of useful that, like, oh, you have a predicate over these types or whatever. They're constrained. You know that it has something to do with queries. So like for the query compiler, a predicate is like literally just a byte string builder, right? So it's basically just a string, right? But then for something like if I make a pretty printer for a query, then the predicate for a pretty printer is going to be something like a string plus precedence information, right? It would be like, if you're familiar, it would be like a shows prec function, basically. So that's why I think this example of a data family is good, is because it's semantically constrained, whereas and relatively closed in terms of like useful instances, right? But these data families are bad because there could be like basically infinite number of instances that are all kind of meaningful in their own way. And that just makes it hard to keep track of, because even though there's relatively few instances for each of these, there's still the possibility like, oh, there could just be many, many more. Like every time I add an endpoint for an image or for a label, it basically means a new instance of this. And there's theoretically no real end to the endpoints that I might be able to add. I don't know if that's debatable, I guess, but anyways, it's a much less closed data family than a predicate is, because predicates are just about queries. But an image is conceivably about most objects in the domain of this program, because it's an image board, right? So nearly everything could be classified in terms of an image, because that is primarily what this program is concerned with, is images in some shape or form. So that's why I think this is bad, and that's why it pisses me off. But that's why I like this data family, because I think it's good and it's constrained, and it keeps things nice and neat, and it lets you write a DSL over a generic data type that you can just decide what it means based on the interpreter that runs the expression, which is super cool. So anyways, that's all I got, I guess. So yeah, bye.